Okay. Hi, guys. I'm Tomasz. I'm so glad you chose my session over lunch over there. I'm really flattered. But anyway, I came today not as a consultant or a Kubernetes trainer. I came today as a frightened Kubernetes user. Because over the years, I've seen how Kubernetes become very, very popular. And at the same time, as you're probably aware, security is not the biggest concern. But where are those LLM models run? Where are those applications generated by AI run? Of course, on Kubernetes. So after the online extended version of this presentation, I got many messages saying that, Tomek, you know what? You spread the panic inside our organization. And we had to fix it very quickly. We had to change our configuration in order to prevent from stealing data, the things that I'm going to show you today. So, is your environment secure? I hope it is. I'll be showing it in a few minutes how you can check it. So, So, let me just start by describing the recent vulnerability found 2 months ago by the Wiz company. And they found very interesting and even more frightening vulnerability. It was found in the ingress-nginx controller. So as you probably know, if you use Kubernetes, so you probably know that in order to expose your application outside of the cluster, you either can choose Kubernetes service with load balancer type, or choose ingress. And how it works is, of course, you need to specify your ingress traffic in ingress specification, send it to Kubernetes, and then you can use it to allow your user to connect to your application, like in this case, to your green pods. So that's pretty obvious. So what they found out, the guys from the Wiz company, is that you can actually exploit this ingress-nginx, exploit its one of the features, or maybe a bug, which is admission webhook. So admission webhooks are used in Kubernetes in order to verify something. And ingress-nginx also uses an admission webhook to verify your configuration that you specified in the ingress-nginx manifest. So they found out that it is actually very easy to prepare a malicious admission review that you can send to your ingress-nginx controller. Why? Because ingress-nginx controller has an endpoint that is insecure. It means that it is not, it doesn't have any authentication or authorization rules. That's insane. However, they managed to use this admission review that they can send from any pod in the cluster to send a malicious admission review which contains some configuration that uses annotation. And I won't get into more details. However, some of those annotations allow them to use a special file. So they could use it to be more precise, to override SSL engine with some shared library. So they used another interesting feature. I'm not sure if you know, but if you send a file to an nginx, or specifically to an ingress, to an nginx configured by your ingress specification, if the file is quite big, it exceeds some threshold, it is written temporarily on a file system, on a file system of ingress-nginx container. So, and additionally, they also notice, which is also very scary, that even though the file was deleted, they were able to access its content using file descriptors. If you know what if you're a Linux user like me, you know that file descriptors are a pretty cool thing when it comes to recovering your deleted file if the handler isn't released by a process. So, combining those two things, they managed to get inside the ingress-nginx container. And that's when things get really scary. Because ingress-nginx has a role attached to it which allows ingress-nginx controller, but also, in this case, attacker, to access any kind of secrets that they want. So ingress-nginx has a role-based access control role that permits it to access any secrets in any namespace. That's pretty scary. How scary? Let's see a very short video prepared by Wiz. So, and I will briefly describe what's going on. Okay, here it is. So, as you can see, at the top of the screen, you see a shell session launched from a container running inside the cluster. At the bottom of the screen, you can see a shell session launched on some workstation outside of the cluster. Okay, so what they did is actually they are opening netcat connection, and this is really interesting. So they are using some Python exploit. This is Python PY, and they are targeting the endpoint of the ingress-nginx controller. They can do it because it doesn't have any authentication, authorization rules, and the traffic to it is open. So what they did actually is they embedded this exploit in a single file, and what you're seeing right now, let me just pause it once again, is they are probing, because they actually prepared this malicious admission review, and also they use this post feature with some big file in order for nginx to create a temporary file, and they are probing all of the file descriptors that are available inside this container using this malicious library. And if they succeed, they are able to open netcat connection, actually open a connection to the netcat, and they are right in the nginx container. As you can see, of course, they are missing some tools, so they are downloading kubectl, some tricks to make it run. Okay, and they are getting all of the secrets from all of the namespaces. That's pretty scary. However, there is one or a couple of assumptions that they did, but I will talk about it in a minute. However, let's see whether is it really that critical. Well, as you probably know, Ingress is an interface in Kubernetes, so you don't need to use ingress-nginx as your ingress controller. You can have any kind of controller that you choose. There are controllers based on HA proxy, Envoy, even Istio has its own implementation of ingress interface. So you can choose whatever you like. However, According to WIS, over 40% of organizations are using ingress-nginx, and that's why it is so scary. Because most people choose ingress-nginx specification because it's stable, it's mature, it's the oldest implementation, to be honest, and it's for free. Of course, we like when things are for free. But the most important part is it is extensible using annotations. So, and these annotations actually were allowing WIS to create this exploit. So we know that it is really critical, really critical. So, but are we all in danger? Are we all in danger if we are using this ingress-nginx controller? Of course not, because you probably upgraded your ingress-nginx controller, didn't you? I don't see panic on your faces, so I'm pretty sure you have your ingress-nginx controllers upgraded, so you're good. However, it's not the last, it's not the first such vulnerability. But I want to stop here and check what assumptions did guys from WIS do. So actually, they managed to create a shared library. So it was embedded in this exploit Python script. They haven't published it yet, and probably they never will. However, in order to create such shared library, you need to have some strong skills. However, we have generative AI, so it's not that hard these days as it was like a year or 2 years ago. But that's not all. They also were able to create pods. Do you need to create pods in your production environment? Of course, you need some pods, but that's why you have GitOps to prevent users from creating their own pods. Okay, that's step one. So probably that's a pretty courageous assumption. So at the same time, they created a pod and they were able to access its environment, access the environment of the container using shell running as a root user. That's insane. And because they had to do it probably because otherwise the exploit wouldn't work. So this is another assumption. So another assumption is that traffic was allowed to flow in the cluster, but also outside the cluster. As you've seen, they downloaded some binary from internet and so on. So they made all of these assumptions, and that's why they were able to create this very short and cool video, which is scary, by the way, for sure. However, it reminds me of something else, something you are probably familiar with, which is Swiss cheese security. So actually, they were able to use to create and to use this exploit because they found many holes in this Kubernetes cluster that they used. So it wouldn't be possible if some of those holes weren't filled by some security measures. But guys, do you actually need to write an exploit in order to hack your Kubernetes cluster? No. No. If we take the same assumptions that WIS took, we could actually hack our own cluster without having to write any exploit. And this is part 2 of my presentation, where I'll be showing you two scenarios of demo sessions, which hopefully which will work and will show you how it's done. Okay. So first of all, before I start, let me just say that I'm not a real hacker. So I understand how Linux works. I understand how Kubernetes works. And I'm also aware of potential risks. And please don't use the things that you will see and the resources that I will share with you at the end of the session to hack someone else's cluster. Just use it to have some fun on your own cluster or to fix security in some other clusters, but don't hack into other people's clusters. That's the disclaimer that I wanted to say. Okay, so I won't be using any kind of special Kubernetes. No, I will use the most popular, which is EKS, so Kubernetes as a service running inside AWS. So my first demo will be about leveraging CRI interface of Kubernetes. So we will start with this state where I will have a user that wants to access someone else's secret, okay? And nothing else, okay? So let me just start the demo. Okay, I'm here. So my demo consists of two parts. I need to prepare somehow my environment. So I'll be using run admin script. These scripts and all of the resources are available on my GitHub, so I will share the link at the end of the session, so no worries. So I'm preparing my victim application, the green one. So I'm preparing my victim application, and also I'm preparing less privileged user, you know, because I won't be doing it using cluster admin role. No, that's too easy. So let me switch to my user. So okay, so now I will use a kubeconfig with less privileged user. No cluster admin or something. No, it's just a user who can create pods. Okay, so now I'm creating my own application. Actually, I need a single pod, and let me verify whether I can actually read pods or secrets from my Kubernetes cluster. Actually, I'm also using this namespace secret too in order to verify I don't have access to it at all. So no, I cannot read secrets. What about pods? The same. So what I'm doing right now is I'm verifying whether I have curl command available inside my container. It's not available. So, oh, sorry, it's available. The other command is not available, which is CRI control binary. So let me use the curl which is available inside the container and download the CRI control. So actually, I'm using the same method as guys from Wiz. So I'm downloading it from internet. Okay. Okay, I'm unpacking my my binary. Okay, and I'm inside my cluster using root shell as guys from Wiz. So what I can do right now is to use CRI control ps command. As you can see, I can see all of the containers running inside the node on which my container is running. So I cannot see my application, okay? So I won't be able to do anything because it's not there. Why? You will see in a minute. So let me just. I won't be able to steal the secret in this case, but I need to make sure that my application, my pod, is scheduled, is running on the same node as my victim application. So I will need to find somehow I will need to find the node's name, actually the host name of the node. So I can do it. In various ways, like for example, using affinity session and so on. But to make it short, I will just use the node from my k9s command. But it can be you can brute force it. You can probe any kind of nodes, any node in the cluster. Okay, so let me just patch my deployment. So actually, I'm using spec node name field, and let me just redeploy my application. Okay. I need to re-download all the files that were missing in my container image. Okay, so once again, I'm downloading my CRI control. I'm unpacking it, okay? And how about now? I guess this, probably, let's just, okay, I guess this is it. So this is the pod name. And what I can do right now is, actually, I will use CRI-ctl, inspect, backend. Oh, sorry, I need to pass container D, not the name. Oh, and now I have access to all of the metadata from the container, but also some metadata from Kubernetes layer as well. But what I'm looking for is some interesting volumes. Let me see. Hostname resolved. No. dbcreds. Oh, okay. So there's dbcreds directory inside the victim's container, and it is available. It is mounted inside the node. So let's see what's inside. Okay, it's not there, but actually it is. I need to just add a prefix host, and okay, here's the password. Here's the password that my victims is using inside the container. So it's done. It's done. So I can actually use this method to access any secret inside Kubernetes, even though I don't have access to its namespace or anything. So okay, so this is the first scenario. But okay, let me just clean it up. Oh, so let me just describe what exactly happened. So what I did is I created a pod with host path volume from my node, which enabled me to access any files inside the node. So I don't need to have any SSH access to my Kubernetes nodes. I can just these 3 lines and volume mount, which is missing on the slide, but it is super simple. So by doing so, I was able to access containerd Unix socket, and I used some environment variables to configure my CRI control in order to access the containerd service running on every node inside every Kubernetes cluster, because that's how Kubernetes works. It needs some container engine. Okay, so by doing so, I was able to inspect the metadata and access secrets. Actually, I could access even some mounted volumes with database files and so on. That's how easy it is. It is really frightening as well. Okay, but that's not all. I have another example. So this time, it's a very similar situation where I want to have access to some secret used by my victim's app, but this time I'm going to impersonate kubelet. Okay, let me just switch the scenario. Once again, I'm preparing my environment. So I'm creating the victim application once again, and also a dedicated user. Okay, now it's ready. So, oh, sorry, kubelet, and once again. So I'm using a dedicated kubeconfig file. I'm deploying my own pod using deployment. I'm waiting for it. Okay. Okay, it's ready. So let's verify. Do I have access to any pods or secrets outside of my namespace? No. How about pods? No. But this scenario is different from the previous one because I'm not using the root account. I'm using some unprivileged user. Oh. End of file. Hopefully the internet still works. Hopefully. So let me verify whether I have curl available. No, I don't have curl available inside my container. So what I'm going to do right now is to download curl, but in a different way, bypassing any firewalls. How? That's very simple. I'm downloading the curl archive on my workstation. So when it's and after that, I'm using kubectl exec to transfer it using Kubernetes API onto the container. Okay? So I don't need any internet access to be able to upload, to make some additional tools available. Okay, but for kubectl, I will use just plain old curl command. Okay, so to make things a little bit faster, I will use it directly. But I could actually do it in a very similar way, download it to my workstation and just upload it using kubectl cp or kubectl exec. Okay, so what I'm going to do right now, I'm going to use kubelet conf file, or kubeconfig actually, to access some pods. Okay, so this is quite interesting because I've done this scenario on multiple Kubernetes distribution, and for example, in Azure, this wouldn't work because there is a different location of this file, which is accessible only by root. But in our case, EKS didn't make very good job securing it, so it is accessible also by unprivileged user. However, I need to become root for other reasons, which I will show you in a minute. So what I'm going to do, I'm going to change my user. I will become root inside my container. So actually, what I'm doing right now, I just patched my my deployment. Let me just display the patch. It is very simple. I'm using security context, run as user 0, and that's it. So there is no such thing as security by creating container images running as non-root user. No, you can always override it. You can always, almost always override it. Okay? So let me verify whether I'm running as root. Indeed, I'm root. Okay, and I need to re-download curl. I need to re-download kubectl. So let's wait a minute. But then, okay, I'm downloading curl right now. Okay, and let's hack. So I'm launching a special command. Let me just show it to you. Oh, first of all, let me just show that, well, I'm still not able to access Kubernetes API. However, what I'm going to do is I'm going to copy my downloaded kubectl file on the host file system, because there is no kubectl binary on my EKS node. Okay, so I've just downloaded it inside my container. I'm using the same mechanism, which is host volume, and I'm making sure that it's accessible from inside the host. Okay, now it's ready. So what I'm going to do right now is I'm going to use a pretty popular back in the day command, which is change root. So what I'm doing here is I'm using kubeconfig to point to the set of files, actually, because the command is universal. It can be launched on various Kubernetes distributions. However, what is the most important part is here I'm just changing root, and I'm launching bash shell inside my new root. Okay, here it is. I can see all the processes running on the container. Sorry, on the node. But that's not all. Now I'm able to use Kubernetes API. Oh, I cannot. What a shame. However, let me just say a few words about it. So it was possible to execute this command a few versions back. However, they changed something, and it's now harder. Let me just change something in my command. So now I need to, because I'm able to list all the pods, but only the pods that are running on this particular node. So I need to use field selector, and I need to specify that I won't list all of the pods running on this particular node. So I'm going to use node name. Oh, what a convenient. So this is the host name, so actually I'm going to paste it. That's it. Now I'm using kubelet's kubeconfig to access my Kubernetes API. So actually, oh sorry, actually now I'm able to list all the pods running on this exact node. So what I'm going to do right now, so I need to know the pod name, so I cannot list, but I can get some details. So from secret 6 namespace, I want some details regarding this pod. Okay, I'm going to use yum output, and oh, okay, there is some secret mounted in DB creds. So what I want to do is actually, this is better option. Secret name. Okay, that's interesting. So can I list secrets? No, but I can access any secret if I have its name. So secret 6. -n secret 6. Okay, that's it. Now I'm able to access my secret, and it's done. I just hacked it using different layer using Kubernetes API. So that's how easy it is. But is it really easy? Why it was possible? So let me just go quickly, briefly through this scenario once again. So actually, I used the same approach with host path volume. I overrided the user using security context, and I was able to use the host file system to access kubelet kubeconfig and to access pods or any kind of information that kubelet is allowed to access. Okay? That's how easy it is. So, but actually, getting back to our Swiss cheese security, it's all about these holes. So how can we protect our cluster? How can we prevent such scenarios from becoming our nightmare? So first of all, create pods. I shouldn't be able to create pods, to be honest. I should have a different role, or maybe no role at all, especially in production. I should have better image. Do I need shell? Really? I don't need shell to run my web service. I can get rid of any shell. It would prevent me from executing anything, but also from uploading anything, because kubectl copy command uses kubectl exec underneath. Also, better admission control would be nice. Once again, I was able to execute a shell session. That's not right. I shouldn't be able. I could create pods, but executing shell, it's a very bad idea. At the same time, it can also be prevented using admission control. I was able to access the host file system, which is insane. It should be prevented also with admission control. I was able to override the user that was defined in the container image, which should be prevented using admission control as well. I was able to download missing tools because, yeah, in most cases, you don't have network access control preventing traffic to the outside of the cluster. So, can you see the pattern here? There are many times on the slide you can see admission control and role-based access control, but let me just stop at role-based access control. If you think that role-based access control can protect your cluster, oh boy, you're so wrong. Really. Role-based access control is only used for authorization part, not the content of the manifest. And as I showed you, especially in the pod manifest, you can use many fields to hack your cluster. So role-based access control is not enough. It's just not enough. Even if you prevent users from accessing the cluster, please remember that you can have malicious images doing the same things. So that's not enough. What is recommended? Admission control. So admission control is a mechanism that verifies, validates the content of your manifests. And I'm pretty sure that you've heard of Open Policy Agent and its gatekeeper component. Kyverno is also a very popular admission controller. So these are external services, but I highly, highly recommend maybe not switching, but considering built-in admission controllers. First is validating admission control, which can do most of the things as Gatekeeper and Kyverno, but most of all, pod security admission. I won't, because I'm running out of time, I won't get into much more details, but by using pod security admission, you're securing your cluster from my scripts being able to hack your cluster, but also preventing the exploit that I showed you at the beginning, and also, which is even more important, from future exploit that will eventually happen. So, how to boost your cluster security? It is super, super easy. Single line, single annotation that you attach to your namespace, and your cluster is, let's say, more secure, but definitely with this annotation, with pod security control, you can prevent those scenarios from happening, from being your nightmare. Okay, so that's it. Thank you for coming. If you want to practice, if you want to use my resources, there are more than 2 demo scenarios that are available on my GitHub repository. And one more information, I just relaunched my podcast Rozchmurzony. I started recording new episodes. If you're interested, then you can listen to it on my webpage or any place that you want. Okay, so I'm ready for some questions if there are any. Thank you so much.
Tomasz Cholewa from Cloudowski, please. Big applause, please.